Welcome again. Dear students, last time we talked, I told you that today you have to introduce how to make the hexagonal headbolt. So today our task is this one. Last time you have been taught how to make blank of bolt. When I say a blank of bolt is where you have performed this work. Here, threading operation. There is here these parts. These parts is where I produce the hexagonal head bolts by using this milling machine. So now today you have to do this task. So before to do that, I have to introduce, first of all, the safety. The safety is very important. While you are going to operate the machine, the first thing which is very important is safety. What is safety? Safety is all measures can be taken for minimizing the accident. Because the motion of cutting tool, the motion of everything here, if you are not careful, the accident can be occurred. That's why some measures can be taken before to operate this kind of machine. In general, in machine tool, you have to apply what we call PPE, personal protective equipment. It's where you have always wear this safety shoe for protecting your foot to be injured by the chip of metals. You have to wear safety glasses to protect your eyes from the chips comes from the metal while cutting. It's better also to protect your body by overall. It's kind of to be uniform and to be smart on the job. The overall is very important, or overcoat. The overall is better for students. To make difference with instructor, the overcoat is better. As the task we have to make the hexagonal head bolts, so first of all, I have to introduce the dividing head, as I said before. So the dividing head, the accessories of milling machine, which is used to fix the workpiece and to divide them into equal amount based a designed product. For example, if we want to cut 6 sides of a hexagonal head bolt, means that one side must be equal to another side, so that you can get the standard, you can achieve the standard of the bolt. That's why the dividing head is there. So the element of dividing head, this part is dividing head. So here we have what we call the dividing head. This part is called the spindle of dividing head. Is where you fix the job. Do you see these jobs like left machine has? It's the same. Here is where we fix the job. And also here we have what we call the indexing plate. Is a very important part of dividing head, which is used to calculate or to account that equal space. And here we have what we call the crank pin. This part is used for transmitting the motion via the worm gear to the worm shaft. Then we get the output motion, but some calculation you have to look before. And also here we have the dividing lock. After dividing, then you lock the dividing head to avoid the rotation during cut. So those are the main parts of dividing head. So now we have to see, we're going to see how is the mechanism dividing head. Dividing head is composed by the worm gear, which is engaging the worm shaft. This is called the worm shaft. This worm gear has 40 teeth of transmission. Here is where we have the dividing head spindle. Of course, with indexing plate mounted on it. Index crank. Here there is the indexing plate hole. Maybe this cycle hole has 55 holes and so on. So means that when you turn, one turn of index crank causing the spindle to rotate 1/4 of spindle head. This is the main principle, the main working principle of dividing head. Means that when you turn the index crank, means that one tooth is engaged to the one single thread worm shaft. That's why one turn of index crank causing the spindle to rotate 1/4. Means that here we can deduce the general formula. One full of index comes from 40 turns of index crank. Then n turns can deduce the general formula. The n division comes from 40 over n. The n is the number of division. This is a simple indexing method should be applied apart from direct indexing. 40 over n. N is the number of division. So the task we have is to produce hexagonal head bolts. Means that we have 6 equal sides. So we can calculate. So we have 6 equal sides of hexagonal head bolt. The formula says that simple indexing method 40 over n, I explained where, means that 40 over 6, because we have 6 equal sides, the number of division. Then we get 6 4 over 6. Here, never write a decimal number, a fraction of a fraction. It's very critical because there is a meaning of this denominator and a meaning of this numerator. We can interpret this where means that 6 full turns of index crank plus 4 holes on 6 hole cycle. I can explain more of that. So this fraction of fraction you have 4 over 6 we have means that 6 full turns of index crank plus 4 holes on a 6-hole cycle. That is the meaning of this fraction. According to the indexing plate, have been discovered by the English sharp, is indicating indexing plate is a round plate which is composed by 6-hole cycle. So those hole cycle contains a number of specific holes. For example, here we have this last cycle hole which contains 59 holes. That is simply the meaning. When we interpret this fraction, means that these 4 holes is the amount of holes have to be added at each division on this specific hole cycle. This denominator value is there for selecting hole cycle. This numerator is the cycle have to be added after these full 6 turns of index crank. So we come back here to our indexing head. The number we have there, how to select the whole cycle. We are going to base on this denominator value. The denominator value is 6. Here, can we find a whole cycle of 6 holes? We never found. Means that there is a way of simplification of a fraction. Multiply both numerator and the denominator, there is no change on our fraction. So here we have 16. Cycle hole means that multiply both numerator and the denominator 5. We get 620 over 30. 4 over 6 is equal 620 over 30. This is my question. 4 over 6 is equal to 620 over 30. This fraction is equal. Because when we simplify by 5 and 5, we get 4 over 6. There is no change. But there is a possibility of selecting the whole cycle as the based on the availability of indexing plate, we can apply this fraction. But there is no change for calculation. Only to match with the availability of the indexing plate in our workshop. Means that 6 full turns of index crank plus 20 holes on 30 hole cycle. Not only this method for making the hexagonal head bolt, but also the direct indexing method. So the direct indexing method consists of using the indexing plate of 24 holes divided by number of division. Direct indexing plate So the direct indexing plate consists of the indexing plate of 24 holes, which is located here. The direct indexing plate is mounted before the indexing head spindle, means that there is no way of GR ratio calculation. Is to calculate directly because there is no GR ratio calculation have been accounted here. only to consider the reference hole. When you start, use the direct indexing pin to the indirect indexing plate as the reference. Then you start to count. For example, to make hexagonal head bolt is to take the 40/6, means that is equal to 40/6. Is it divisible? No. Means that I mean for 24. 24 divided by 6 is equal to 4. Here we have to account 4 holes at each side cutting. Is how we proceed the direct indexing method. It consists of 24 holes indexing plate, which is all number divisible to 24 can be applied to this method. If you want to divide, for example, 24/4 is equal to 6. And even here should be applied. Here there is a limitation. If there is a number of division which is not divisible to 24, there is a limitation because the small number it is not used. Is where we introduce the simple indexing method, 40/n. Then indexing plate technology should be applied here. This method is limited to the number of division to 24. But if some condition limited here, apply this method. But not only those methods, another method should be applied. But your level, you must to use well the direct indexing method and the simple indexing method or plain indexing method. So now we start the practice of making hexagonal head bolts. First of all, make sure the dividing head is fixed well. How the dividing head can be fixed well is to check if it is fixed in parallel to the table of milling machine. Make sure the dividing head is fixed in that condition. It should be to the parallel of this line of T of the table. Make sure this side should be parallel. You can check by using the vernier caliper by this method. Where you can check this side. Should be equal to here. Is to check the parallelism. Then you tighten the bolts for fixing. Clamp well the dividing head on the milling machine table so that it can move. So after fixing the dividing head, remember to fix your work. Dividing head, milling machine, spindle, clamp well into the jaws. What is next is to mount the milling cutter reserved for facing operation. Because we are producing a flat surface as the side of a hexagonal head bolt. That's why we fix the vertical milling machine cutter so that we can perform that operation is to produce a flat surface of hexagonal head bolts. That's why to choose this specific milling cutter. You tighten well. So now the cutter is well fixed in the milling machine. So here you have to choose the direction of cutting. There is one factor based for choosing the direction of machining is to see the direction of the inserted carbide cutter, how it is. It is clockwise direction, is why I choose the clockwise direction. So this is the right direction of machining. This direction is from how the inserted carbide cutter is. It depends on the geometry of that inserted carbide cutter. If you choose wrong direction of cutting, means that the cutter should wear very quickly and it cannot cut properly. Here we have to make clearance position. When I say clearance position of workpiece is to approach the workpiece near to the milling cutter. Before approaching the workpiece to the milling cutter, there is a gap between the cutter and the job. That is the clearance value. It is better to stop away enough bit, then use the manual control to avoid the accident. Before cutting, measure the diameter of hexagonal head bolt. Is a 41. Is a 46. Then the size of our hexagonal head bolt is 41. Means that 6 millimeter will be removed. On a radius, you have to remove 3 millimeter. Zero touching to the workpiece. Okay, do you understand the sound? zero touching. We set z-axis to 0 so that we can read the measurement. As long as we set the depth of cut, we can read here. This is very helpful. So now we can take 1 millimeter, set the depth of cut of 1 millimeter. You see, 1 millimeter should be removed. Let the coolant speed off. Then take the feed. Now the machine is cutting the side of hexagonal headbox. 1 millimeter, it has been removed. Then we take 3 millimeter at once. Take the feed very careful. Base the material being machined. If it is hard, go slowly. If it is soft, go very quickly. Now indexing, direct indexing. Unlock the indexing lock. Then we are going to account 4 holes for cutting the next side. As our calculation said there, for direct indexing, 24/6 is 4. Means that 4 holes at each side of hexagonal headboards. 1 hole, 2, 3, 4. 4. Then lock the direct indexing plate. Then we have to cut the second side of hexagonal headboards. Second side already produced. Next indexing, unlock the direct indexing lock. Then we account 4 holes from a starting point. 1, 2, 3, 4. 4. It's okay. Third one is being cut. Oh, the last one. Maybe? Yes, it's the last one. Amazing. The last surface is produced now. We finish our job. Very slowly, as long as the feed is progress. Amazing. A head of hexagonal headboard already produced by milling machine. Switch off the machine, then we remove the workpiece there. Split off, split off. Hello? Hello? Do you see? Hexagonal head bolts. 6 equal sides have been produced by milling machine for performing face milling machine by using the special accessories of milling machine, which is called the universal dividing head. Now, every student have to be able to produce the bolts. Here you can clean by using a file. I think you have been taught well the bench work. That's why the bench work first. Then you clean your work after production. Okay? So next time, we can close here by this job. So I want every student to be able to produce a standard bolt. Of course, there is a need of ref machine operation and also a milling machine operation by performing face milling operation. Okay, thank you. So next time, we'll see how to produce a gear by applying a simple indexing method. Since here we have applied the direct indexing method.